Okay. So before to discuss today's topic, I want to recapitulate what we have discussed in last week briefly, so that you can properly understand uh, our today's topic. Actually, whatever we have discussed till date, it is simply the introduction of computer. Which book you have to refer? So you might have seen here the William Stalling, the book name William Stalling, Computer Organization and Architecture at Edition. So actually, I will provide this book to you uh, through the Moodle. I will share all the details with you very soon, and even you will get the PPT as well as the book soft copy through the Moodle. Okay. So what we have discussed till date, in the first lecture, we have discussed functional unit. So in the computer, basically it is divided into three functional unit like input, output, memory, and the processor. Input, output devices, the memory, there is a primary and secondary memory, as well as in processor, there is a ALU as well as a control unit. So these five different units we have seen here, how the wire carry your data in the form of 1 and 0. We have seen how the different line coding schemes are there, right, in our previous lectures. The next topic is that is architecture and organization. So in architecture, we have seen architecture attributes are visible to the programmer. Generally, it is used for lower level concept like instruction is a lower level basic logical unit is there, and the programmer knows all the instruction. So it comes under the architecture. For example, suppose if you want to multiply, the programmer know what are the instructions are available. So what does system do? All these things comes under the architecture. Simply by this way you can understand. And organization means how. Like in the architecture we have seen, suppose if you want to do multiplication, then what are the instructions available? So this is what, that is architecture. What does the system do? Yes, he do the multiplication. The programmer knows what are the instructions. But the organization means, organization is how features are implemented. Okay, so if you want to do a multiplication, how this multiplication implemented? Either by the multiple time addition, it would be possible, or direct multiplication feature is available. So you can easily remember the architecture means what and organization means how. I explained the same concept with you with the and with one analogy that if you are buying a house, in a house, the architecture means you are identifying how many rooms are there, uh, the what is the area of the house, the build-up area. So all these things comes under the architecture. Even the water supply is there in the bathroom, balcony, terrace. So that comes under the architecture. Means what are the facilities are available. And the organization means how actually you are getting water in balcony, in bathroom, on terrace for the terrace gardening. So that comes under the organization. How actually the pipelining connection is there. So by this way, actually, you can properly understand the difference between architecture and organization. As well, in the last lecture, we have discussed structure and function. So structure means is the way in which the components relate to each other. How in a computer there is a different components are there, how these components are related to each other, how their connection is. Function means is the operation of individual components as a part of the structure. So in a structure, we have seen multiple components and which are related to each other. And the function means the individual component. What are the operation of individual component that comes under the function? We have seen various functions like the data processing, data storage, data movement, and the control, right? So here we have seen how the different components are there and which are connected to each other, and each component having its own function. It perform its particular operation. We have seen the different types of operation, like how the data movement is there in between the two components, how the data transfer from external environment to computer storage, here how the data is moving. And here we have seen how the data is taken from the storage, and after processing again, the data stored into the memory. So processing from the storage. Again, here another example, we have seen like data en route between external environment to storage. How the data is moving from the external environment to the storage. So all this comes under the function. These are the different components, and each component performing different types of function like data processing, data storage, data movement, as well as control. So function means the operation of individual component. Data storage having its own function like to store a data movement, it carry your data from one component to another. So it comes under the function. And structure means how the different components are related to each other. So here actually we have seen the different types of structure. Here I discuss with you, like if you want to understand a complicated thing, how we can understand by the hierarchical way. We can use either top-down approach or a bottom-up approach to understand a complicated thing. So definitely the computer is also one of the complex architecture. Here millions of different electronic devices are used to build a computer. With the use of these different electronic components, the different components are created. So mainly, actually, broadly, if we speak about how the computer can be broadly categorized, in the top level approach here, we have seen the computer we can categorize into different components like a central processing unit, input, output, memory unit, and system interconnection. So we have seen what is a CPU, what is a main memory, what is the input, output, and system connection. Again, if you open a CPU, obviously it is a top-down approach. It means now you will open one component and look what is inside the particular component. So that is a structure. And if there is a multiple components are there, how these components are related to each other. So here actually you could see there is a different components and how these components are related to each other. Like CPU, there's a registers are there, ALU is there, control unit is there, and there is an internal CPU interconnection is there. By this way, the CPU is built. Similarly, the control unit. So all things comes under the structure. So I hope you understood. Up to here, we have seen in last week. Now today, we'll see the next topic, that is how actually your computer executed the instruction. Again, actually here it is the basic introductory topic. Everything you know, but this discussion is required because by this way you will come to know how to write answer or how to answer for this kind of question. Actually here one Voneuman machine for complete whatever I will discuss here. This discussion is completely about the Voneuman machine that was introduced very first. By considering that the first computer, I will discuss these different components. Okay, so don't compare with today's computer. It is very introductory. To understand this concept, I am taking okay. So earlier I was recapitulating. That's why I'm discussing with you speedily. Now I will discuss the next topic because one of the students sent the our the sound is breaking in between. So I hope the you should be in the your network range so that you will not face this kind of issue. Okay. Our next topic is program concept. Okay, in the program concept, now here you have the, seen before the computer there is a different devices where you could do a different types of mathematical operation like a calculator. So consider a calculator and the hardware systems are inflexible. You can understand this statement. How the calculator is inflexible because a calculator perform only the function that is implemented to develop a calculator. Implemented in a calculator. Whatever the functions are provided. If it is a basic calculator, you will find a basic mathematical operation. If it is a scientific calculator, you will find some logarithmic and this kind of extra functionality over there. So the calculator can provide you only the functionality that is developed in a calculator. So it is inflexible. But if you compare with the computer, computer is a very flexible. You not only perform some mathematical operation as well, you can perform the different types of operation with the computer. Again, it is depends upon your program. Again, it is depends upon your program. So general purpose hardware can do different tasks given a correct control signal. But if we are talking about the calculator, even the calculator perform a different types of tasks. If you want to perform addition, subtraction, multiplication, division, yes, you can perform these different types of tasks. And for these different types of operation, definitely there is a different types of control signal is there. If you are performing addition, yes, there is a particular type of control signal. If it is multiplication, there is a particular types of control signal. So even there is limited functionality, it is not very flexible. But whatever the functionality implemented in the calculator, we can use all the functionality and every different task having a different unique control signal. For addition, there's a one control signal. For subtraction, there's another type of control signal. So here in a diagram, you could see we are simply providing a input to the one sequence of arithmetic logic function is there. You can consider it as a calculator. In calculator, simply you are providing a data and a particular arithmetic operation you want to perform, and you will get the result. So here actually how you are using this programming in a hardware, whatever you have implemented through the hardware, only this kind of functionality you can use. So instead of rewriting supply a new set, so this is a very inflexible. So what we can do, we can provide a new set of control signal here, and by this way, even we can perform different types of operation, which is not possible by only this type of hardware. So how we can do this? For each kind of operation, we provide a unique code, unique control signal. So here in the diagram, you could see what we have connected. We have connected one instruction interpreter. So you are providing an instruction in the form of code. Here you are providing instruction in the form of code. And the instruction interpreter interpret the instruction so that your hardware can understand the instruction and send a control signal to the hardware. Here it is a general purpose arithmetic logic unit function. It take a data. For example, suppose that you have provided an instruction for addition, and here you have provided a data, for example, 5 and 8. So this control signal get for the addition, and it will provide the addition in between 5 and 8, and you will get the answer. But this time I have provided, I have sent a control signal for the addition. The next time I want to perform a different types of operation. Yes, it is possible because we are giving instruction separately. But if you will consider our previous example, in our previous example, the the complete your arithmetic logic function is implemented in hardware. Here we cannot change the functionality like in a calculator. You cannot add a new functionality by yourself. So, but here if you are designing a new system where you are providing a separate instruction code, there is one instruction interpreter who are converting your instruction in different form of control signal, and with this different types of control signal, there is uh, the another hardware who execute your instruction based on the control signal. So different types of things we can implement here. So hardware segment accept the code and issue the control signal. So for this kind of implementation you have seen in a computer. So we have a computer in which we provide the instruction uh, code, and there is one hardware who execute the instruction. Then what is a program? In Python, you might have the Jitendra sir have discussed with you what is a program, as well as in first year in C, you have learned lots of things about the program. So what is a program? Program means a sequence of steps. In program, you will find that there is a sequence of steps. The number of instructions are there, right? To get a particular output. So for each step, an arithmetic or logical operation is done. So if you might have implement a different program in which you will perform a different types of arithmetic operation, as well as you use a different types of logical operation. And for each operation, there is a different set of control signal is needed. Because in one program, the many time we use a different types of mathematical operation as well as we use a different logical operation multiple time we execute. So the logical operation require. So for to execute these different things, always we require a different types of control signal. Earlier, like a calculator, we cannot provide this kind of control signal. But in computer, through the program, we can provide these different types of control signal. So as I told you, actually, I'm talking about one Voneuman machine that that was implemented at the beginning of when the computer was developed. That time, according to the Voneuman machine, in the computer, mainly there is a three components. The first component, that is a control unit and arithmetic logic unit. The control unit and arithmetic logic unit constitute the central processing unit, CPU. We have discussed in the previous lecture. In the CPU, there is a control unit as well as ALU, arithmetic logic unit. So CPU is one component. Second component is input-output unit. Through the input-output unit, you can provide a data as well as instruction. So data and instruction need to get into the system, and through the output system, the result is out. So one is your CPU, second one is input output unit, and third one is a memory. So one more component required, that is a memory, because temporary storage of code and result we require a memory. So broadly, we can categorize our computer into three categories, where there is a central processing unit is there, input output is there, and main memory is there. So as I told you earlier, I'm talking about Voneuman machine. That's why I'm not considering there is a primary and secondary memory. Simply, one memory is required for these different types of operation. That's why I'm talking about only the main memory. So in computer, broadly, we can categorize into three components: CPU, input, output, and main memory. Okay. So here, if you uh, again, this is a diagram of Voneuman machine. Here, the CPU, in CPU will find some registers are there, main memory is there, and input output module is there. So in main memory, if you see the per CPU, in CPU you will find the different types of registers, as well as ALU is there. So these different registers like MAR, memory address register, MBR, memory buffer register, input output address register, input output buffer register, PC program counter, IR instruction register, and execution unit, that is ALU. All these things under the CPU. The second one is the main memory. Here you will find there is a numbering 0, 1, 2 for the each byte of data. For the, this is what you can say, this is addressing for the memory. And here you will find there is a instruction and the data in the main memory. So it is in the binary form, no matter it is instruction or data, it is in the binary form. And the third one is that is the input output module. So we have seen these three modules: CPU, main memory, and input output module. Now why there is these different types of registers are there? So actually the first is a PC, program counter. So at the beginning when the execution start, the PC hold one instruction. So here uh, the PC hold one instruction that want to execute, having the instruction address. So that instruction address copy into the MAR, that is a memory address register, who hold the address of memory. It can be the instruction or the data. So the PC hold the instruction address and he passes to the MAR, and this PC incremented by 1. So if there is no any kind of control signal is there, like a jump, or the incrementation is not the sequentially like 1, 2, 3, 4, the PC is incremented by 1. For example, at instruction 1 to execute for the address of 300. So PC hold the 300 number, that is the address of instruction. This 300 number passes to the MAR and PC incremented by 1. If there is no any kind of other control signal is there, now the PC hold 301. Now the MAR having address of 30. MAR having address of 300. Okay. Now suppose at the 300, this is the instruction. So this instruction will be loaded into the MBR, memory buffer register. As I told you, but the instruction and data is for the same. because both are the binary. So here the whatever the instruction is there, it will be the instruction will be loaded into the IR instruction register. And for to execute this instruction, suppose a data required and the data is here. So that data loaded into the MBR. This data is loaded into the memory buffer register and this instruction loaded into the IR. And after the PC program counter, the name is counter, it means it is incremented. So it is incremented by 1 and it hold a new address that is 301. So sequentially the PC incremented if there is no any kind of other control signal is there, like a jump or this kind of signal. So it is sequentially incremented. So after 300, it is incremented by 1, that is 301. So instruction register is there who hold the instruction and MBR who hold the data. Memory buffer register or memory address register. Sorry, memory buffer register. And memory address register who hold the address of instruction or address of the data. So if the data is, for example, the 301, here MBR hold the 301. MAR hold the 301 and the data loaded to the MBR. It is depends upon the instruction. Now, why these two registers are there? IOAR and IOBR. So by their name only you can easily understand. It is for input output address register and input output buffer register. Suppose this through the input output unit, if you want to store an instruction into the main memory, so we can this input output buffer through the system bus data will be stored into the main memory. And suppose if you want to submit this data to the CPU, so that time input output unit can send the data to the CPU through the system bus. So address register who hold the address and buffer register means who hold the instruction or the data. So address means to hold the address and BR means it's hold a data or instruction. Now suppose here your instruction is loaded into the IR. This instruction will be provided to the execution unit, ALU, arithmetic logic unit. This ALU execute the instruction and after execution, the result would store into the MBR. Because whatever the result is there, it would be stored into the MBR. And from the MBR, according to the respective address, the result again stored into the main memory. So in this way, you will find in the computer, your instruction will be executed. So it is very simple how the computer execute the instruction. So tomorrow, with the help of example, we will see how actually the complete execution is there by considering again Voneuman machine. With the help of example, I will show you exactly how the PC hold the instruction, how the memory address register hold the instruction address, how the MDR, memory data register, or you can say MBR, memory buffer register, who hold the data or instruction, and how the IR hold the instruction and executed. After execution, how the data stored into the memory. Tomorrow we will discuss with the example so that you can properly understand. So in computer, basically, there's a two types of function. So that is the fetching the instruction and execute the instruction. So we can say the computer having a basic function, that is execution of program. So how the program can be executed? The first instruction fetching required and then the execution required. So the instruction processing consists of two steps. One is the fetching and the second one is the execution. Fetches means the processor read the instruction and execution means to execute the instruction. So the processing required for a single instruction is called instruction cycle. So actually, if you want to execute a one instruction, the first step is that we have to fetch the instruction. The first step, to fetch the instruction. So after fetching the instruction, then we have to execute the instruction. So fetch cycle is there, execute cycle is there. Many times, whatever the result is there, again we have to provide to the next instruction. So here is the loop you could see for the height. So we can say this complete processing required for a single instruction is called instruction cycle. So for one instruction execution, the fetching and execution is required. So we can say it is a one complete cycle. Halt means what? If suppose the computer turn off, the power cut or because of any reason it turn off, or there is unrecoverable error occurs, that time we can say it is the halt. The computer is in halt state because of the computer turn off or unrecoverable error. Okay. So already actually I discussed with you what is a fetch cycle and execution cycle. But again, I want to discuss the same thing. What is a fetch cycle? Fetch cycle means there is a program counter PC hold the address of next instruction to fetch. Okay. So remember this complete fetch cycle because tomorrow among you, one of the students have to explain the same concept. Okay. And then I will explain you with the one example. But the concept is very simple. So understand here properly so that tomorrow you can explain. Tomorrow I will announce the name from here and you will have to explain, okay, with the example. So it is very simple. There is a PC program counter who hold the address of next instruction to fetch. We have seen PC is there, who is holding the address of next instruction to fetch. Then processor fetches the instruction from memory location pointed to by PC. So PC holding the address. So what the processor will do, he will fetch the particular instruction from the memory location. Which memory location? The address, the one who is holded by the PC program counter. Okay, तो PC ने जो एड्रेस होल्ड करके रखा है वो एड्रेस पे जो भी इंस्ट्रक्शन होगी प्रोसेसर क्या करेगा, उसे फेच करेगा यानी उसे लोड किया जाएगा, राइट, फर्स्ट स्टेप. आफ्टर दैट PC incremented unless told otherwise. So again it is depends upon your next instruction. It is not the case always sequentially one by one your instruction will be executed. Sometime the jump is there or suddenly the instruction changes. So accordingly the next instruction address would be added into the PC. Again he hold the next address. Okay. So instruction as I told you, जो PC का जो PC ने जो एड्रेस को होल्ड किया था मेमोरी से उस पर्टिकुलर एड्रेस पे जो भी डेटा होगा उसे क्या किया जाएगा, the data will be loaded into the IR, instruction register, IR. So instruction loaded into the instruction register, IR. Then processor interpret the instruction and perform required action. Okay, so now in the IR, the instruction is there. Now what the processor will do? He interpret the instruction. He understand the instruction because your instruction is like it is add R1 comma R2. Like this kind of instruction is there, like in assembly language. So the first, the processor have to interpret the instruction. What is the meaning of the instruction? And then he take a particular action for the execution. And in execution, what happens? Generally, you will find these four things will happen in execution cycle. Like processor memory, data transfer between CPU and main memory. So either it may happen your data move in between CPU and the main memory. So data movement is there because the respective data will be loaded. Then processor input output, data transfer between CPU and input output module. So data movement again in between the CPU and input output. Then data processing, some arithmetic or logical operation will be performed on a data, or the control, like alteration of sequence of operation, as I told you. It, for example, 300 instruction, the next instruction would be 301 address, the next instruction would be 302 address, and the next instruction would be 314, because it might happen there is a jump instruction. Or maybe the combination of the different types of operation, like a data movement in between the processor and memory, in between memory and input output, or after data processing, again the data movement is in between processor, memory and input output. And there is at the same time different types of control operations. So we can say these different types of operation will be performed in execution. So to do fetching as well as execution, different types of registers are required. Already we have seen these different types of register. Instruction register who hold the address of instruction, who hold the instruction, not the address, who hold the instruction. PC program counter who hold the address of instruction. General purpose registers are there. For the arithmetic logical operation on ALU, that there is a general purpose registers are there. Again, memory address register who hold the address of instruction or data, and the memory data register who hold the data. So actually tomorrow we will discuss the same thing, whatever we discussed today with this example, how actually these different the instruction fetching and execution happen. Okay, so if you have any doubt in today's topic or in our whatever we have discussed in previous topic, you can ask here. So session is open for the question answer. If you have doubt, you can put your question in the chat box. Because whatever I have discussed, which is a very basic fundamental thing, that you should remember, because whatever I will discuss further, which is related to the same thing, how actually computer holding an address as well as a particular instruction will be executed. There is a different the purpose of register. So this is a very basic concept, and as it is, you should remember. Yes, any doubt? If you have any doubt, any question, you can put your question in through the chat box. Okay, no question? Are you there? Are you there? Acknowledge through chat box kindly. Are you with me? Okay, thank you. Okay, thank you. Otherwise, what happens generally, it is like one-way communication. I'm keep discussing, and all you people are sleeping over there. It should not happen. Otherwise, I'm keep discussing here, and you people are not there. Okay, because we don't know when the situation will recover, but the situation would recover very soon, because today there is a news, like Indian company have uh, developed a vaccine, and it will be in the market on 15th of August. So very soon the situation will recover, and it may happen there will be the theory paper exam. Okay, so yes, yes. Uh, Vaccine. I'm talking about vaccine. I'm not talking about the coronil. I think coronil is the name of Baba Ramdev medicine. Huh? Today, yes, vaccine announced on 15 August. If the vaccine really came into the market on 15 August, very soon the situation will be recovered. So you attend all the lectures, take it very seriously, because we don't know what will happen if you are not taking seriously. Again, you will face a problem. Okay. And the next thing you should, because I have seen few students have not login uh, according to the format. Only they have login with their name only. Even the roll number was not present. If again it will happen, I will not consider their attendance. Okay. So you should remember, you should join for the session according to the format the department have provided, like a class underscore roll number and then name. But this way only we can monitor your attendance properly. Because if the many students are not specifying their roll number, there is only the name. Two students are specifying only the roll number, uh, no name, and two students they are not specifying anything. So it would be very difficult from our side. So you should properly uh, while joining a session, you should check your name. Okay. So briefly, within 5 minutes, I recapitulate our today's lecture, and I stop here. So today we discuss with the simple concept, like the hardware system is how it is inflexible, like a calculator. We cannot add extra functionality. The calculator could provide you only the functionality that is implemented in a hardware, but we can develop a system by which we can provide we can provide a different types of instruction to the hardware system, and that different types of instruction can be executed. So we can add a functionality into the hardware system. It is not like a calculator. It is a new hardware. So that is called our computer, today's computer, in which we can provide a different types of instruction, and the computer execute your instruction. So in the instruction, we provide instruction and the data. So this instruction is nothing but your program. So set of instruction is your program. So in the program, there is a arithmetic and logical instruction. So for each arithmetic uh, operation as well as logical operation, there is a unique control signal is there. So we have considered Voneuman machine, in which broadly we have categorized computer into three categories, like CPU, input, output, and main memory. So here is the CPU, main memory, and input, output, and how the instruction executed, and again the result back stored into the main memory, or it is sent, or the result sent to the input output module. So broadly, to do this, to execute one instruction, one execution cycle is required. And one execution cycle we can categorize in two parts, that is a fetch cycle and execute cycle. So in execution, we can say in execution cycle, it can be the data movement in between the processor to memory, processor to input output, or the ALU process your data and the control unit is there for the control operation. As well as we have seen these different types of registers. So this is the topic that we have covered today. Tomorrow we will discuss the same thing with one example, how actually your instruction executed. Okay. So